All right, hello and welcome to the next episode of 3Din30. What's new? A Velo 3D Rapid and TCT preview. So, in case you're new to 3Din30, 3Din30 is Velo3D's LinkedIn Live and YouTube Live channel. We host this about every 2 weeks or so, depending on the trade show schedule. So it will vary a little bit. And we like to dive into a lot of different topics. So, follow Velo3D if you want to hear the latest schedule. Follow us on LinkedIn to get that schedule. Today, we're really excited to talk about the show season. So it has been a long time since we've been able to meet up face-to-face with a lot of you, and we're excited to be attending Rapid 2021 in just a week. In addition, we love sharing our metal laying parts with the market. Our parts tend to get a lot of attention at shows. They drive a lot of buzz. This year will be no different, and we're going to have a great show. So we're planning on inviting everybody over to booth E7607. You can't miss it. It's like the second row right as you go in. So it's a great spot to come in and see some of the latest cutting edge technology. Today, we're giving you a sneak peek. So if you're interested in seeing what we're going to show at Rapid, we'll give you a little bit of a taste for that. Helping me out today will be Velo3D's own VP of Global Sales and Business Development, Dr. Zach Murphree, and two of our technical experts, Ben Wilson and Ryan Askew. All three of us all four of us rather, will be at the show. So let me turn you guys on here. There we go. Welcome to the show. How's everybody doing today?
Doing all right.
Doing good.
Great. Awesome. So, if you're just joining us, as a reminder, this is a live session. We love to take your questions. We want to hear from you. So give us some questions or just give us some reactions on social media. Let us know how we're doing. Very excited to hear from all of you today. So Zach, I'll start with you. What are Velo's plans for Rapid?
We have quite a few plans for Rapid. I think our biggest thing is to show off some of the new parts, the new capabilities. I think since the last show we had, which was a couple years ago, we have a lot of new developments in terms of systems, materials, and we really want to show those to people in person for the first time in a long time.
Awesome. And in spite of the backup signal that I'm hearing in somebody's audio, we are definitely going forward with our technology. How's that for a segue? So what can we expect to see at the booth this year? What kind of new things are you bringing?
Parts, lots and lots of parts. I think, one of the things that we really tend to focus on as a company is what you can do with the technology. So we'll absolutely have these parts that demonstrate just what I was talking about, different machines, different capabilities, alloys. We have live demonstrations of our software. So if you're interested in learning more about what Flow or Assure can do, we'll have those and private meeting rooms too. So if you want to set up a meeting, we'd be happy to host you and go into more detail on your application or our technology.
And I noticed that you and Ryan have masks, which obviously, in the season of COVID with trade shows, a lot of precautions. So maybe give folks who are unfamiliar a bit of a background. What is the show doing and what is Velo doing specifically around COVID?
Yeah, so the show is being held at McCormick Place, and McCormick Place has a policy requiring masks. So I think everybody at both Rapid and FabTech will be required to wear masks throughout the show. Velo specifically, our employees are required to be vaccinated. We have a pretty strong stance on that, hoping that everybody who can will get vaccinated. But kind of following the show guidelines around mask mandate for the show and trying to have partial face-to-face conversations in spite of it.
Yep, and obviously all four of us will be there as well. All four of us have had our shots, so we're ready to welcome some folks. So we did talk about some new items, and we were curious what everyone was most excited about. So we held a poll, and we hosted this one on LinkedIn. This is what you've told us that you're most excited about. So we looked at new metals, new systems, new capabilities, new applications. A lot of interest in capabilities and applications. And I'm kind of curious, and maybe from Ryan's point of view or Ben's point of view, you guys live in the application space. What makes applications so exciting and capabilities so exciting? There's a lot of interest there.
Well, to me, it's getting to see what all these different customers are doing, new exciting parts all the time. We have quite a wide breadth of types of customers, different industries. So it's always exciting just to see what people are up to and what we can do to help them, achieve what they're trying to get. So.
Sweet. And I understand you've got a lot of parts there sitting on the table, Ryan. So but we'll get to that in just one second. I do want to spend a little bit of time on systems, though, and metals, kind of setting a groundwork. So, Zach, let's talk a little bit about systems. What are the varieties of systems that are available today for Velo?
Sure. So since 2018, we've had our standard Sapphire system on the market. This is the 315 millimeter diameter, 400 millimeter Z height, dual laser, 1 kilowatt laser metal printer. Recently, we've released the Sapphire 1MZ, which is the meter tall version of the standard Sapphire. So it's a 315 millimeter diameter build plate with a full meter tall height. You can print some pretty interesting high aspect ratio parts. We have a lot of interest from rocket companies, from downhole tool manufacturers, other people who are really looking for tall parts. And then for me personally, I think the most exciting machine that we have that we're going to start delivering in December of this year is the Sapphire XC. And XC stands for extra capacity, and it truly does have some ridiculous capacity. It's a 600 millimeter diameter build plate, 24-inch diameter, 550 millimeter Z height, which is a 22-inch Z height, 8 1 kilowatt lasers, so you can really rip through some material. And just watching it build is it's pretty amazing. It is definitely a beast.
Very nice. And then on the metal side, maybe if you could give us some background on where we are in terms of the metals.
Sure. Yeah. So we started with some of the more traditional materials in terms of nickel superalloys, titanium. We've expanded our material capabilities quite a bit, I think, in the last year, especially, to now include different Hastelloys, 625 as an Inconel, aluminum. So we have F357, which is kind of like a aluminum silicon 7. So slightly better mechanical properties than the ALSI 10 that a lot of people are used to. We also have a new aluminum alloy that is released that we'll be talking about a lot more at Rapid. But this is a high strength aluminum alloy that we now have our parameter sets developed for. And then, the upcoming materials are also really important. We won't necessarily have those at Rapid, but it's a good thing to be aware of on the copper front, as well as a couple of other kind of high performance alloys, stainless steels, etc.
So let's talk about this new aluminum alloy. Ryan, I think you've got something for us there.
I do. So this is a part that we printed in-house on our new aluminum alloy reactive system. This is a manifold. I can't go too much into the application of this part, but basically it transfers a fluid or fluids from point A to point B, usually from one inlet to multiple outlets or vice versa. So with this part and using that high strength aluminum alloy with the inherent low density and the ductility of aluminum, it actually lends itself well to a manifold like this.
Cool. And what would somebody be looking for if they're trying to print this? Like, what would drive them to using printing as a manufacturing choice?
So looking at this picture, the main thing you can see is it has basically this inner manifold, and it has this outer kind of shell. So it's basically assembly consolidation is one of the driving factors. So the ability to print, both these elements in one monolithic part is super important. It basically eliminates a assembly step. The other thing is basically complexity is free, is what I like to say. So you see all these mounting brackets everywhere, all these ports for sensors, these flanges. You can basically add as much complexity to this part as you want without really adding to the print time or print cost. So you can really jam a lot of different features into one monolithic part.
Yeah, you can really tell it's light. You can tell the weight of it. It's pretty
Absolutely.
cool.
Mine's very strong, just to be clear.
Either that or he's yoked. So Ryan, this was done with the dual laser system, right?
It was, Yes, there was 2 lasers on this part. This is printed in the center of the build plate. And if I can, you can see it in person better at Rapid, but if you try and find the stitch line where the 2 lasers basically meet, it's pretty much impossible. So we have very good laser alignment.
Cool. So that's a good challenge. So if you're in the mood for a challenge, come by the Velo booth and try and find our stitch lines. It's virtually invisible. Pretty awesome technology. So want to switch a little bit to some of the hot topics. So we talked about, audience wants to hear about capabilities, and I know we've been pushing the boundary on capabilities for a while. Zach, where are we with capabilities? Like, what are the differences with the Velo system?
Yeah, I think we've generally, for the past several years, led kind of the capability discussion, especially in terms of our low-angle overhangs. I think that's something that Velo's been known for since the beginning, right? Being able to print overhangs without supports. And we've continued to really iterate on that and expand that capability. I remember at Formnext in 2019, we were advertising that we could get down to 15-degree overhangs, right? And we've continued to push that really aggressively. So we have some really good examples of, this is something that's analogous to like a shrouded impeller, right? This would be the top shroud of the impeller. We've cut it in half so you can see the underside of that shroud. This is as printed, so no finish machining. And this is a 2-degree shroud printed at a 6-inch outer diameter. So the diameter of this is about 6 inches. And the surface finish on the inside is pretty phenomenal for a 2-degree shroud without supports. And right now we're pushing this to be even bigger. And as we go to the XC system and start to be able to print impellers that are 500 millimeters in diameter, it becomes really important to have this type of capability to really unlock those critical applications.
Nice. I actually have a zoom in here if anybody really wants to get a good look at this. It's pretty amazing technology. And this is a part that they'll be able to look at the show as well, right?
Absolutely.
And maybe if you could explain, how do our customers or how do contract manufacturers get a hold of this technology? Do they have to pay for it? Is it additional charges?
No, what we sell is the capability to print the parts that you want. We don't sell a machine. We don't sell the software. We sell a complete package, right? And that's a really important thing for us to make sure that everybody is aware of. And so if somebody has our machine, if somebody has our system, they're able to print everything that we can print. And the updates are essentially pushed out as we get new capabilities. They're driven into the field so that they're available to everyone.
And we had a question from Austin about the Sapphire XC. Will this system be able to use all 8 lasers at the same time to print at 8 times the speed as if you had a single laser?
Absolutely, yeah. I mean, that's part of the whole point, right? It's not just to print bigger parts, but it's to print all parts much more cost effectively, essentially. And I think, you look at a 8 laser system, 1 kilowatts, that's 20 times what the standard single laser 400 watt system has in terms of laser power. So yeah, when it comes to comparing throughputs, it is definitely kind of bleeding edge.
Nice, a lot of power in there. Cool. Let's see here. Oh, now we get into applications a little bit. So there were definitely some questions on applications. I'm going to bring all of us back here because I've had a couple chats with Ben recently on some applications. So Ben, you and I have worked on a part recently with the Velo Virtual series, and if anyone's not familiar with Velo Virtual, we do deep dives into applications. It's a webinar series that we are running, and we had one recently. Maybe you could kind of talk about this and give us some of the history on this part.
Yeah, Zach, I don't know if you could pull up the static mixer there, or Mike, if you can pull up the picture. But so what we're showing here is this. It's a static mixer, which can be used in a variety of industries. But basically, what it is just a motionless device that is used for mixing fluids that are passed through it. This part in particular was a joint effort with our friends at ANSYS. What we did really was we meshed the power of our support-free printing and their physics simulation to produce a part that it maintained the design intent without making any significant compromises to it for the sake of manufacturability.
And what, maybe you could give us an idea, why would somebody want to print something like this just in general? Is this normally printed, or do you normally use this some other technologies to manufacture this?
Yeah, so traditionally, this part would likely be made in several pieces. In each of those pieces would require their own manufacturing processes, and then they all have to be assembled. So by 3D printing it, you can consolidate that assembly and reduce your BOM. Really what you're doing is reducing the complexity of the part and reducing the number of failure points you have in your supply chain. And in a lot of cases, this can save you in time and cost both. So,
and in terms of pushing this and printing this on a Velo Sapphire, what would drive someone to do that?
Yeah. So really printing this part in a traditional additive system would probably be pretty tough. The baffles on the inside, for instance, those grow at about 20 degrees. They'd be very challenging on another system. You'd likely just have to support the inside of them, and that would make them unreachable. It wouldn't be very practical to try to remove the supports there. And actually, there's a lot of surfaces on this part that would require either supports that would be unreachable, or just require design modifications that would compromise the design intent. So rather than having your manufacturing process, suit your needs, you're actually having to compromise the design and the performance for the sake of manufacturing.
I know one of the questions we had was, are the inlets and outlets, were they open during the print? I think.
Yeah. So we printed if you pull that part up a little bit, there's some circular channels that were printed on the ends. And those were printed totally support free. They maintained circularity rather than having to make them like the traditional teardrop shape or something that you would do on another system to make them more printable. That way there was no changes in the flow characteristics, and the design intent was maintained.
One of my favorite parts about this also is that when you look at the baffles that are on the inside of the part, it's incredibly difficult to tell the orientation in which the part was printed, because the surface finish on both the tops and the bottoms is really excellent. And I think that kind of it speaks well of what we're able to do for the low angle printing.
Yeah, it's you've got an image, which is one thing. A video is a little bit better than an image, but nothing replaces seeing this part in real life. So another part that we're going to show at Rapid. So a couple other applications. I know there's one that we haven't been able to get on Velo Virtual. Really excited about this part. Ryan, I think you have this one with you as well. And I know this is another part we can't talk about the customer. So, what is this part for? Maybe if you guys can show this one.
Yeah,
got a couple images here.
Yeah, this is a turbine engine component that is it's actually it's turning out to be quite a success story for one of our gas turbine partners. It's actually an assembly of over 45 parts that's been consolidated into one and then printed in Inconel 718. And this half of the part, you're seeing some as printed surfaces and some machine surfaces. There's another half of the part that Ryan has there where the surface finish was really cleaned up really nicely. It's almost a mirror finish by working with Microtech. But the part you're seeing here is actually a scaled version of the part to prove out feasibility on our standard Sapphire. But the final part will actually be scaled up and printed on our XC system in the future.
How many supports did that have internally then?
That was nearly support free. This whole part. So there's a lot of shallow angles that just took advantage of our low angle process.
Really nice looking part. What would you mentioned consolidating a lot of different parts? So traditionally, how would you manufacture this, and what are people looking to do when they print this?
Yeah, so this would probably be made of several pieces of sheet metal, maybe some castings and some machine pieces, and then all those would be assembled in some way, welding things, brazing, things like that. but really, those all require their own supply chain and their own quality assurance. And the same thing that came up with the static mixer. It's just a lot of added complexity and potential sources of failure in the supply chain. So, yeah, in the same way as the static mixer, and you might end up saving a lot of time and cost and overall headache by 3D printing this part.
And I know, Zach, you mentioned how many internal supports are there in this, which is just kind of a little bit of foreshadowing into the next question. But what does Velo bring to this part specifically that would be a business driver for the customer?
Yeah, so there are a lot of geometries on this part that they wouldn't be printable on other systems without support. Like there are several internal overhanging surfaces that print at very low angles, and similar to the static mixer, you'd have supports in there if that wouldn't be reachable. So by doing it on our system, you're able to print that without having either design modifications or it supports in unreachable areas. So yeah, it's the same thing as where you're trying to make a manufacturing process that suits the designer needs and doesn't compromise performance and design intent, which the Velo system allows for. So.
Also, and just for anyone who's watching the show now, if you do have any questions, any interest in either the systems that we're bringing to the show or that we talk about at the show, the metals that we're bringing in, the applications, the capabilities, any questions about Rapid in general, this is a live sessions and we would love to hear from you. So just post them in the comments and we'll address your questions right away. Very cool. Well, I think we've run through most of our parts. What are you guys most excited about with getting back to the show season? So Zach, maybe we'll start with you.
Yeah, I mean, I know it's probably what everybody is saying, but I'm just really excited about seeing people in person and having those interactions. I think, face-to-face interactions beat Zoom or other platforms all the time. And being able to actually hold the parts and kind of see physically, run your hand over surface finishes, that's invaluable, especially when it comes to, showing what the technology is really capable of. So I'm excited to be there.
Ryan, what are you most excited about with Rapid?
So obviously, as an application engineer, I'm all about the parts. So just being able to show off the ones we've shown, ones that we've shown in the past as well for people that haven't seen them. Just being able to talk to someone about a part while holding it in your hand, showing them the exact areas on here that didn't require supports that we printed. Even seeing the machine surfaces and what our metal looks like on the inside. It's very powerful to be able to hold the part in your hand, feel the weight of it, and realize that this is a real part. So I'm very excited to show these to kind of the whole world, whoever stops by our booth. So,
Ben?
Yeah, for one, I'm looking forward to reconnecting with friends in the industry and just seeing what all the other companies and everything have out there. It's their latest and greatest, and then getting the opportunity to show off our systems and showing off the technology that we have. And really, informing people out there of how we can help enable parts that they might not be able to do other ways. So,
yeah, I know. I'm kind of with everyone here with the parts. I love seeing the reactions that people have to the parts. When you get them in their hands and you ask them, find the overlay and they can't, or like what Zach said, find the top or the bottom. A little bit easier to find the top or the bottom, but it is kind of fun to look at that with like the static mixer and the vanes. And that 6-inch disc is going to be amazing to see the reactions that people have to that. I just don't think anyone's ever seen that before. So, the parts that we're bringing in, obviously they're parts that can be manufactured no other way. So nobody's ever had a chance to see them before, and this will be the first time. So I'm really looking forward to seeing the reactions on it. We did have a question here. Ben, you mentioned Q&A. Does this include adherence to tolerances?
Yeah, so what I was referring to when I mentioned that was, out in your supply chain, you're going to have, several different manufacturing processes that you're going to have to monitor at this point. Like if you aren't 3D printing a consolidated assembly. So it's just kind of like tolerance stacking. You're going to have a lot of sources of variation in your assembly in the end. Is what I was trying to get at.
Okay, very cool. Well, what I mean, we've got a week to go, so I know we've got to get these parts packed up and ready to move out the door. And I know Craig's ready to get his hands on them. So let's close up here. Closing thoughts around some of the parts or applications or systems. Closing thoughts around the shows. We'll go in reverse order, and then we'll tell everyone thank you. So Ben, I'll turn to you first.
Yeah, I'm excited to see everybody there. Please come talk to us. I love talking about 3D printing in general. So come listen to a nerd talk about it for a while if you want. And yeah, looking forward to it.
Great, Ryan.
Yeah, I mean, I'm mostly really excited about the 1 meter Z system. We've seen a lot of rocket engine applications that we've printed in house. Basically, being able to print a chamber nozzle and even an injector manifold all in one monolithic part in one print is just incredible. So I'm really excited to talk more about that machine.
Very cool. And Zach, I'll let you have the last word.
Yeah, no, I think this is a pretty tremendous opportunity, especially after the last 18 months of no shows, to really be in a space where we can talk to a large number of people and show them what we're capable of, show them where we're headed as a company. I think the future is incredibly promising for additive manufacturing and for Velo3D specifically. And the more people we talk to, the more people seem to be convinced that this is the way of the future. So just excited to get out there and be doing that missionary work again.
Awesome. And I would like to say, if you want to have a meeting with Velo3D, we're going to provide a link in the comments section so you can request to have a meeting at the show. So feel free to click on that as a special gift to people who are watching this show. We're going to provide that link for you. So thank you for joining us today. Please make sure you follow Velo3D to get our latest show schedule. We've got a lot of things planned for Q4. We're starting to ramp up. We're going to have some great guests join us very soon. So, and thank you all for joining us today. Thanks, Zach, Ryan, and Ben. And thank you, audience. That's a wrap.
Thanks.